An emblem, as shown in the diagram above, consists of a triangle ABC joined to a sector CBD, of a circle with radius 4 centimeters and center B. The points A, B, and D lies on a straight line with AB 5 centimeter and BD 4 centimeter. Angle B, A, and C equals 0.6 radians, and AC is the longest side of the triangle ABC. A, show the angle ABC is 1.76 radians. So we need to show that that angle here, because we're looking for the letter in the middle of the three letters, so that will be the angle we're looking for, angle B. So we want to show that that equals 1.76 radians to three significant figures. B, find the area of the emblem. So we're going to do A. For A, we need to show that the angle here is 1.76. To do that, we start with pi. Pi. To do that, we'd start with pi. Pi equals 1. Oh gosh. To do that, we'd start with pi. Pi equals 180 degrees. And that equals 3.142 roughly radians, or you might write 3.142 rad. And the total angle in a straight line is 180 degrees. That means the total angle, or the total angle in a triangle, equals 180 degrees, which means equals 3.142 rad. Now, what we need to find is, we're given these points, these angles here. We know this angle and we know this side, opposite side. We know this side there, we don't know the opposite angle. So we may need to find the opposite angle here. So if we label this angle here, capital C, and this angle capital A, now we can use sine rule. Sine of capital C, the one I'm looking for, over little c, this side here is little c, should be equal to sine of capital A over little a. This side is little a. And to find c, capital C, we have to say sine capital C equals, if I multiply both sides by little c, so that will cancel this c in the denominator, so I get c sine capital A over little a. Now, if I divide both sides by sine, so I get c equals 1 over sine, open bracket, little c sine capital A over little a, close bracket. And now 1 over sine in indices is sine to power minus 1, open bracket, little c sine capital A over little a, close bracket. So I've made capital C the subject. Now I can plug in the data I need. Now to do that, I need to make sure the calculator is in radians. If you check the top of your screen, it will say R or D. If it's in D, that means it's in degrees. To change it to radian, you need to press Shift, Menu, and you will see it says number 2 angle unit, select 2, and number 1 is degree, number 2 is radians, select 2 for radians, and then it will show back on your top screen as R. That means it's in radians, because we are working in radians here. So now we can plug in those values and we can calculate C. So for C, we can have inverse sine, open bracket, 5, because little c is 5, times sine 0.6 divided by 4, close bracket. And in this case, you get C equals, press Shift sine to get the inverse sine. And then you press the fraction key because we're dealing with a fraction here. The fraction key is below the option button, so press fraction key. Then 5 times sine 0.6, and then press the arrow down to get to the denominator. Put 4 there. Press the arrow to the side, right hand side, to then close the bracket. And then equals, so which C will be 0.7836 radians. Right, so now that's what C is. Now, we now need to find, so this value here is 0.7836. Now we now need to find the angle B here. To find the angle B, that will be pi, because pi is the total angle in a triangle, which is 180, and pi is 3.142. So pi minus 0.6 minus 0.7836. And if we plug that into calculator, you could do shift times 10 to the power x, that will give you pi, minus, or you can just type in 3.142 minus 0.6 minus 0.7836, and you will get 1.7579. They want the value in 3 significant figures, so that would be B equals 1.76 radians. And that's the answer we are looking for. Question B, we need to find the area of the emblem. The emblem consists, it's a compound object or compound shape. It's got the non-right angle triangle and the sector joined together. We need to find the area of that. So that means we need to write down the area of non-right angle triangle and the area of sector. The area of a sector is a half r squared theta. And theta is in radians, don't forget. This angle here is 1.76. Therefore, this angle here that we need here is going to be pi minus 1.76. That's the angle there, because pi is the angle in a straight line. And so that will be theta. And r are the radius. So these are the radius there. So that's the radius and the radius. And to plug that in and find the value for that, so it's going to be a half times 4 squared times, so pi minus, so we got, so that would be 3.142 minus 1.76, and that gives times 1.382, and that gives, so we times that by 16, 4 squared is 16, and you divide it by 2, and we get 11.06 roughly centimeters. That's 40 centimeters squared. So that's the area of the sector. Now we need to find the area of the non-right angle triangle. And in this case, it is a half because we know this side is A and that side is C. So I have AC sine of B. So this is B here, sine of B. And we know the a half times A is 4. So that's 4 times C is 5 times sine 1.76. Again, you have to make sure you're working in radians. So check the top of your screen to show that it's R, and then you do 5 times 4 is 20. 20 divided by 2 is 10. So 10 times sine 1.76, close bracket, and we get 9.82 centimeters squared. So that's the area of the non-right angle triangle, and the total area of what we're looking for. So the area of emblem will be the area of sector plus area of non-right angle triangle, and that would be area of sector was 11.06 plus 9.82 for the non-right angle triangle. We add them together. 9.82 plus 11.06 shall give 20.88, and to three significant figures will be 20.9 centimeters squared, and that's the area of emblem. That's the area we're looking for.